This is problem number 5 from the circuits review packet. It reads 2 light bulbs, one rated at 30 watts and one at 120. Oh, I'm sorry, 30 watts at 120 volts and another at 40 watts at 120 volts, arranged in 2 different circuits. The 2 bulbs are first connected in parallel to a 120 volt source. Determine the resistance of the bulb rated at 30 watts when it is connected to the circuit. This is an interesting question. Power, as you're aware of, is equal to the product of voltage and current. And when you buy a bulb at the store and it says that it's rated at 30 watts, that's based on the assumption that, at least in North America, you're attaching it to a 120 volt circuit. So in this case, 120 volts is the voltage, and the current, I could substitute for I V over R. So we know via Ohm's law I is equal to V over R, so this becomes basically V squared over R, or 120 volts squared over my resistance. And so therefore the power is based on a known resistance of the bulb and a known power supply, which is nominal as long as you're in the same region, in this case anywhere in North America for us. This assumption will come out to play later on in the problem. Determine the resistance of the bulb. So we're simply going to use this relationship that power is equal to V squared over R. Solving for R, I get R is equal to V squared over R power, or 120 volts. I need to square that, divided by my power of 30 watts, which is the rating of the bulb, and I get 480 ohms. Okay, so now that I know the resistance of this 30 watt bulb is 480 ohms, let's see how that compares to the 40 watt bulb. Of course, we'll use the exact same equation, V squared over R. We get 120 volts squared divided by my power, which is 40 watts, is equal to the resistance of the bulb. So I kind of did a little bit of rearranging between this step and this step. And so 120 volts squared over 40 watts gives me 360 ohms. So now you can see, if you didn't already know, that the resistance of the larger, more higher rated bulb, 40 watts, is lower. The lower the resistance, the higher the current that can flow through it. Okay, so let's go ahead and move on. Now part B says the bulbs are now connected in series with each other and a 120 volt source. Determine the resistance of the bulb of the 30 watt when it is connected and the 40 watt. The resistance doesn't change. It's a function of the bulb. So we still have the resistance of 480 ohms for the 30 watt bulb, and now we just need to find its current. So now what I'm going to do is basically say that I've got the total resistance, or the total current flowing through these resistors in series is going to be the total voltage. This is the total, the voltage supplied by the power supply over the total resistance. In this case, it's going to be 120 volts over the sum of the two resistances because they're in series. So 360 ohms plus 480 ohms. And I get a total current in this case of 0.143 amps, or 143 milliamps. So resistance is the same, 480. I should write that. Now it looks like, now that I take a closer look, it looks like I've skipped the question about the current. So let me go ahead and do that in red for both problems. Current, of course, is voltage over resistance. I've just manipulated Ohm's law, and in a parallel circuit, the voltage dropped across both of the bulbs will be the same. So I get 120 volts over 480 ohms, and that gives me 0.25 amps. 0.25 amps for part 1. And for 2 down here, of course, I'll just do the same thing. Current is equal to voltage divided by resistance, and I get 120 volts over a smaller resistance of 360 ohms. and I get 0.33 amps. So I wanted to make sure I got those done. Looks like I had skipped them on the first pass. So moving back down now to part B, we want to know the resistance of the 40 watt bulb. It also doesn't change. So I'll go ahead and write that. The 40 watt bulb has a resistance of 360 ohms. This is a property of the bulb filament, and so I can say that that doesn't change. And the current is going to be the same. These are in series, so the current through the first bulb is going to be equal to the same as the current in the second bulb, so we know that these are the same, and I can then say 0.143 amps. Okay, so let's keep going. Now the part C says, in the space below, number the bulbs in each situation described in order of their brightness. The brightest bulbs are going to be in the parallel circuit. I've got 120 volts. The 40 watt bulb, of course, has the most current going through it. It's got the lower resistance, so it's going to be the brightest. It's got the highest power rating, so that should be 1 Q for you. The second brightest bulb is going to be also in parallel here. That's the 30 watt bulb. It's got a little bit more resistance, a little less current going through it, and the power rating is smaller. The next two are the toughest ones to kind of wrap your head around. Now that they're in series, the wattage rating of the bulbs is a bit counterintuitive, and the reason is these ratings, these nominal ratings, are based on the fact that you've plugged them into a parallel circuit at 120 volts, which you now have not done. It's a series circuit. So the 30 watt bulb has a higher resistance. They have to have the same current going through it. So the easiest way to wrap your head around this series portion is to just simply recognize that the power is equal to the voltage times the current. And the voltage in each case is going to be substituted in order to see it more clearly by current times resistance. So I'm going to basically now get I squared R. That's the power delivered by each bulb. Again, now that they're in that they're being arranged in series, I can't use that power rating. The current is going to be the same for both. So in the 30 watt bulb and the 40 watt bulb, because they're in series, the current's the same. However, the resistance is lower for the 40 watt bulb. We saw that up in previous portions. So I have a smaller resistance here in the 40 watt bulb. I have a larger resistance in the 30 watt bulb, and so therefore I'm going to have a larger, actually, since they're arranged in this way, a larger power here. So that's how I basically finish numbering those 3 and 4. The total power dissipated by the two bulbs in each of the following cases. Parallel circuit's quite simple. I simply add those two powers together. The total power in the circuit is simply the power of bulb number 1, which is 30 watts, plus the power of bulb number 2, which is 40 watts. No problem, I got 70 watts here. The series circuit's a little trickier. I have to do some calculations. The total power is going to be the total voltage times the total current, or in this case 120 volts times my current, which I calculated previously of 0.143 amps. When I do that, I'll see that I get 17 watts. So I have much more power delivered to the bulbs in case 1 parallel than I do in series.